Hello, this is Alan from Chef. In this video, I'm going to show you how to create a Ragdoll simulation with atoms. So, first things, let's set up our agent type with the Ragdoll setup. So let's create a new, let's call robot. Now let's set the atoms Ragdoll that we exported. Okay, now our agent type is ready, but we can start to lay out. And create an agent group. Let's start with a single one. Let's create an I field. Let's select our new agent type. Okay, now you can add the Ragdoll module. The things, just enable physics. Let me scale because I'm centimeter here. Okay. So obviously if I press play, nothing happened because the Ragdoll module is not working right now because it's mode 0. So let's switch to Ragdoll. It's going down. We need to set up a collision ground. So let's create another polygon. I would suggest to have two separate meshes for the I field and the physics ground. A little bit offset with the two. Okay, so now let's create our rigid body and static plane. Press play. And we can move a little bit the plane up. If you want see the actual rigid body meshes that are simulated, you can select the agents. So agent selection and turn on the debug. The debug mode will display the rigid body mesh for only the agents selected. Okay, now let's see what you can do with the Ragdoll module. So let's switch one. Here it is static mode, so you will see red. You have the kinematic. So the kinematic is basically the rigid body simulated, but the transform is driven by the crowd animation. So if I switch to state 1, you see the animation are driving the rigid body meshes. And Ragdoll mode is the normal Ragdoll. So partial Ragdoll. So the partial Ragdoll, you can enable only specific joints, and you can do with a filter like this. It means that every joint will turn in a rigid body, or you can apply some filter like left arm, like that. Now, as you can see here, let me switch to skeletal mode. By default, it just basically turn on the a single joint here because there is this option on. it means that basically just ignore everything else on the hierarchy. So if I turn off this one, press play, you see this one is driven by the kinematic, but this one no. So you can create like some chain simulation if you want. It will simulate the rigid body in between. Okay, let's switch to motor ragdoll. So the motor ragdoll is basically the rigid body are fully simulated by the solver, but physics apply some motors on top of the constraints, and you can control the attributes of the motors or from the setup scene when we exported the ragdoll setup, or you can control using this attribute here, using the damping, the stiffness, if it's acceleration, and the max force. So for example, if I put a really high damping and stiffness, it will follow almost 100% the animation. So basically now the rigid body maintain the ragdoll maintain the last pose of the agents before atoms turn in a ragdoll. You can play the animation you want using the animation blending. So with animation blending, the ragdoll still up playing the animation. Obviously, you can put like intermediate value. Let's put some less value here. Okay, so now let's see. The last one is a partial ragdoll. So it's like the partial ragdoll, but using motors. So it's exactly the same. You can control with the same attribute here. So now let's have a look how you can switch mode here. So let me switch set to kinematic. So one way is to add keyframe here if you want. So for example, you can put a keyframe here and then on the next one switch to ragdoll. Really simple. Or you can control the mode using metadata. So let me remove the animation here, and let's create an area trigger. Let's put another trigger here. So let's switch to the wireframe shaded. Okay, and now let's add an area trigger. Such mesh. So the metadata that is controlling the dynamic state, the dynamic mode is called dynamic mode. And use the same value of the mode here. So if I go inside and put the value 3, it will turn in a ragdoll. So before we can play, we need to tell the module to use the metadata. So just turn on that one and let's play. So in this way you can control the mode with the metadata using the area trigger and or other custom module if you want. In the version 3 there is also another new option for the area trigger that is called as volume. So in this way you can use proper volume here to check if an agent is going inside. instead to have just a plain check on 2D. With this volume, we'll check in 3D if the agent is inside the volume. Okay, so let's have a look to the other parameters here. Okay, so the dynamic on collision. Obviously, in some situation, you want to convert your kinematic, your ragdoll in a your kinematic ragdoll in a dynamic ragdoll based on some collision events. For example, if some rigid body is colliding with your agents. The dynamic on collision tell you which mode use when physics detect a collision between an agent with another rigid body. So let's create an example. Let me switch this one. Let's create a cube. Okay, let's add some keyframe rotation. I don't know, right here. Now let's convert to a rigid body and set this one as a kinematic object. So if I now press play, nothing will happen because I need to select this guy here, and basically I need to switch to the on collision to Ragdoll. Okay, then now press play. Oops, I think the other plane's too low. Wait, behind this one. And now basically my Ragdoll is turning in dynamic mode when it's colliding with the other rigid body. So here you have all the different mode. So you can switch to a partial Ragdoll, or a motor Ragdoll, or a partial motor Ragdoll. For example, here, switch to one. Let's create some more agents. Let's move a little bit. Okay, let's have a look to the other parameter. So the one is breakable. So you can break some constraint joints based on the forces that are applied. So for example, let me switch to one single. Okay, so if I turn on the breakable to yes, and I want to break the left arm, break force to something 100, probably is too low. And basically now you see that the joint is breaked here. The two forces, one is for linear forces, and the other one is for the torque. Yes, sorry, I forgot one thing here. The collision force threshold. So you can basically turn, let me deactivate this one for a moment. You can switch the dynamic mode of an agent also based on the force that are applied to a single agent. So for example, let's add out force module that basically apply a force to every rigid body. So if I go here and I switch to Ragdoll, and the force threshold, let's put to something 100, and here let's put direction magnitude, okay. Let's one is too low, probably. Oh, sorry, let's switch to should be fine. Yeah, it's too much. Let's put this one and let's sorry, let's decrease this one to 50. And this way we can, like, for example, we can add keyframe to this one and go here 100. So you can switch basically just switch the dynamic mode based on the force and not on the collision if you want. It's really useful, for example, with fields. So for example, if I create physics fields like a radial field, and I put here, let's put magnitude to -50. Let's put more, -200. So let's have a look to another parameter that is the stack on collision. Stack on collision basically creates a runtime, a constraint between two rigid bodies that are colliding together. This option here works here if it's colliding with another agent. So for example, if the other agent is an arrow that is colliding with the agents, then it will create, the physics will create a fixed constraint that. But here let's have a look with the normal rigid body, that it's exactly the same, the same parameter, stack on collision. So if I press play, as soon the box will collide, as soon the box collide with the agents, a fixed constraint is created here. Let me switch this one to Ragdoll. It's colliding. There are some other parameter for the constraint that is created that you can control with the on-collision brake force here. So if I put like 100, something like that, it should break. Yeah. As soon the force go over this threshold, then the collision is breaking. Let's have a look. So the last option is self-collision. So it means that the rigid body inside an agent is colliding with all the other rigid body inside the agents. So if you turn on, you have interior collision inside a single agent. If it's off, then it just doesn't check the collision between every pieces. So obviously you can create a constraint at force, or create a rigid body at runtime with Python. So everything exposed. So have a look to the API, and you can create rigid body or create constraint as you want. The last things is about these two parameters here inside the solver. So basically, this enable the collision check between kinematic and kinematic objects. The collision check is used to turn the mode of a rigid body, for example, to turn a kinematic in a dynamic. And if you turn off this one, basically, if you have two agents that are colliding and this one is off, none of the agents will turn in a dynamic mode. Same thing here for the static kinematic. So if this one is off, the physics solver will not check collision between these two to be able to switch to the dynamic mode.